Alright, welcome again in another tutorial of the topic differentiations. So in this tutorial tunaendelea na applications of differentiation to some practical problems. So let's solve this example. You see, it says square pieces are cut out of a square sheet of metal. Umeona hizi, hii ni square piece, square piece, square piece, square piece and square piece, okay? So as shown in the figure. Kwa hiyo hii ilikuwa ni moja, baadaye ikakatwa vipande. Pengine nimechora vibaya, okay? Labda hivi vipande vyote vilitakiwa vionekane kama square. Anyways, you get the point, okay? So square pieces are cut out of a square sheet of metal as shown in the figure. And the remainder is folded about the dotted line so as to form an open box. Manake kipande hiki kitasimamishwa. Yani kipande hiki cha kati tu ambacho ni dotted line kitabaki kimelala. Hivi vingine vyote vitasimamishwa. Manake itatokea nini? Boxi. Okay? Itatokea nini? Boxi fulani ambalo kwa juu liko wazi. Okay, so if the length of the edge of the square sheet, yani urefu kutoka hapa mpaka hapa, okay, ni 0.18 meters, okay? So this length, maana is a square, maana na huku pia ni 0.18 meter. Kwa hiyo na huku pia ni square, okay? Find the maximum volume of the box, okay? Sasa unajua box, tumesema box itatengenezwa hivi vipande vikiinuliwa. Sasa tafuta volume, okay? Sasa hivi vipande vikishainuliwa, okay, si itakuwa box kama hili. Okay, it's just gonna be this kind of box. So you see kama hivi. So kuju kuko wazi. So umeona hii dotted line ndo hii. So volume manake ni A times B times H, okay? This is a volume. Okay, length times 8 times width, okay? So this is a A and this is a B. So this is a, if vipande vikishainuliwa, now this is a H, okay? Manake na huku pia ni nini? Ni H. Alright? So it means huku ni H patainuliwa na huku ni H. So you can see that, I mean, A plus H ni sasa na 0.18. So A plus H ni sasa na 0.18. Na B plus H ni sasa na 0.18. Anataka tutafute the maximum volume of the box. Now let's go. So I mean, nimesema kwamba A plus H ni 0.18, okay? Na B plus H ni 0.18. So I mean, it's just A plus 2H ni 0.18 na B plus 2H ni 0.18. Sasa volume tumesema sasa na A, B, H. So changamoto tunataka maximum volume, okay? Lakini tuna unknown nyingi sana, okay? So hatuwezi ku differentiate zote tatu, okay? We just need one unknown in order to differentiate. Sasa, so I mean, you can see from this one now that A is just equal to 0.18 minus 2H. And from this one here, B is just equal to 0.18 minus 2H. So my volume now is just going to be equal to A, which is 0.18 minus 2H, times B is 0.18 minus 2H, times H. Like that, okay? So this is my volume now. So my volume is just going to be equal to 0.18 times 0.18 is 0.0324. Then we have 2AB, means this is negative, so it's minus 0.72H plus 4H squared times H, okay? Kwa hiyo nikiexpand hii napata hivi, okay? So bado nimesahau H, so na nyetu ingize ndani, it's just 0.0324H minus 0.72H squared plus 4H cubic. So this is my volume now, okay? This time we have only one unknown, only one independent variable. So, okay, my volume, V for volume, okay, is just 0.0324H minus 0.72H squared plus 4H cubed. So nataka nipate maximum volume, okay? So niki differentiate with respect to h nikapata 0, okay? The h I get here will give me maximum value, okay? Refer video ya maximum and minimum values, okay? So when I differentiate this now with respect to h, okay, hapa nitapata 0.0324, okay? Minus hapa hii h square ukidifferentiate unabaki 2h. 2 times 0.72 is 1.44 h. Okay, hii nikidifferentiate napata 3h square. 3 times 4 is 12h square. Okay, derivative of polynomials. Tumeshafanya sana. By now you should be able to differentiate this using your head. So now this, all of it, 0, it should be equal to 0, okay? So the VDH should be equal to 0. Now this is a quadratic equation, eh? So you can use a calculator to get the values of h. So I get h is equal to 0.03 or 0.09. You can use your calculator to get the values of h in this quadratic equation. So these are the values of h. Now, will these values of h give a minimum or a maximum value? In order to determine that, I need to find the second derivative and see whether it will give positive or negative for this value, and whether it will give positive or negative for this value. Then I'll be able to determine which of these two will give a maximum volume, okay? Which one among the two will give a maximum volume? So, my dV dH is just 0.0324, okay? Minus 1.44 h plus 12h squared. So if I find the second derivative now, it means I differentiate this again. So it's a constant, just becomes 0. Here will remain as negative 1.44 plus 24h. This is what will remain. Now, when h is equal to 0.03, what is it going to be? You find that this second derivative will be negative 1.44 plus 24h. It's going to be equal to negative 1.44 plus 24 times 0.03. So, I mean, this second derivative now, you can use your calculator here. You just obtain is negative 0.72. So, I mean, h equal 0.03, the second derivative is negative, okay? This means that 0.03 will give the maximum volume, okay? Will give the maximum volume. What about sasa for 0.09? Okay, so my second derivative now, nimeshaipata. Nimesema ndo hiyo, inaitwa negative 1.44 plus 24h. So this time h kumbuka ni 0.09 kwa sababu kumbuka kwenye ile quadratic nilipata majibu mawili, 0.03 or 0.09. So this one now, for h is equal to 0.09, it's just going to be 24 times 0.09. So itakuwa jibu ni ngapi? Use your calculator there, you get positive 0.72. So it's a positive value. It means this one will give the what? The minimum volume, okay? Lakini swali kwa nataka nini? Swali kwa nataka tutafute maximum volume, okay? So remember, volume ilikuwa ni sasana ngapi in terms of h? Tulisema ni sasana 0.0324h minus 0.72h squared plus 4h cube, okay? So ni h gani natupa maximum volume? Ni hii hapa 0.03. So our maximum volume now, maximum volume will just be equal to 0.0324 times 0.03 minus 0.72 times 0.03 squared plus 4 times 0.03 cubic. So our maximum volume now, you can just use your calculator there, will just be equal to 4.32 times 10 power negative 4. What's the unit for a volume? Meter cubic. So this is our maximum volume. So that's about the application of differentiation to some practical problems. Let me just say, see you in the next tutorial.